the first step that we do is we take the first equation. Okay, we take the first equation, and what we do is we substitute the x value of the second equation into the first equation. Alright, so try and bear with that. So we're going to have x plus 1, that's equals 10, that's the one we're going to work with. And we're going to replace the y with the x value from equation 2. Alright, and the x value from equation 2 is 4x. So what we're going to end up with is x plus 4x equals 10. And what we want to solve for is x on its own. So we've got 1x and we're adding 4x's to it. What do we have, Jaden?
5x.
We have 5x equals 10. And so x is going to equal 10 divided by 5. So x is going to equal 2. Okay? Now stop me if I've gone too fast there, but I don't think I have for any of you. We believe x equals 2, so what we do is we then grab the value that we think it is and we put it into equation 2. So we now reckon that x equals 2. Y equals 4x. We reckon x equals 2. So y is going to equal 8. Are you okay with that so far? We reckon y equals 8. We reckon x equals 2. We can check it. We can put it back into equation 1 or equation 2. Equation 1 looks pretty easy. We reckon x equals 2. We reckon y equals 8. It's got to equal 10. And yes, it does equal 10. So we solve for them. Let's have a look at this one. Okay? What would be the first thing that we'd have to do here? Jaden?
Put 2x into where y is.
Into equation 1. Terrific. Equation 1 looks like that. Equation 1, equation 2. We're going to get rid of this. And we're going to replace it with that from equation 2. So we're left with x plus 2x equals 3. Cam, how can I simplify this? 3x equals 3. So x will equal, Cam? Sorry? X equals 3 divided by 3. X will equal 1. Okay, you okay with that? So we reckon x equals 1. What's the next step that we have to do, Jess? Sorry? Put what we thought we've calculated into equation 2. Okay? We think it's 1. Y equals 2 times 1. Y therefore we reckon but is equal to 2. What's the step to do, Riley? Yeah, what would be the next step, just so we're pretty confident we've got it right? We could put the x equals 1 and the y equals 2 back into equation 1, couldn't we? X equals 2. X equals 1, we believe. X equals 1. Y, we believe, equals 2. Lo and behold, it should equal 3. We know we got it right. Okay? So that's working with simultaneous equations. The process is to grab that first equation, or where the number is the subject. Yeah? The number is the subject. Get rid of the y value and grab the x value from the other equation, put it in there, and solve for it. When we've solved for it, we then put it into the second equation. We reckon x now equals 1. 2 times 1 equaled 2. And then we put both of these back into equation 1 just to check it. We just do a quick check like that. Alright. Now, any questions with that, or can I explain it better? I think Jaden and Jess is now when you stop listening. Alright? But this will be up obviously on YouTube, so you can check out where we go from there. Alright? So if you go on with that, and the rest of you keep listening that are listening. I now want you to look at question 5. Question 5, and what we're looking at is maybe 3x take y equals 9, and y equals x take 1.
That's the next thing that I'm going to be doing.
Yep, so keep listening if you want. So the process doesn't change. The process doesn't change. We've got equation 1, we've got equation 2. Alright? So the step is we grab equation 1 where the number is the subject. Okay, and we get rid of y and we replace it with whatever the x value, whatever this is in the next equation. Alright, so this is 3x take 1. You okay with that? You alright with that, Dooks? Yep. So 3x take x take 1 equals 9. And now we've got to solve for x. We want to solve for what x is. 3x take x, Michaela?
2x.
Yep, 2x take 1 equals 9. What could we do with this is we could bring it over. 2x equals 9 plus 1, so that equals 10. Not going too quickly, am I? X will equal 10 divided by 2. X, we believe, will equal 5. Okay? Then put that known value into here. Y equals x take 1 into our second formula. Y equals 5 take 1. Y will equal 4. We believe that. We'll put it into our equation. 3 times 5 take 4 doesn't quite equal 9, does it? Where have I gone wrong? 3 times 5 take 4 is 15 take 4. 15 take 4 is 11.
Is it where you, at the start in the first equation, is you took kind of the y away, so you meant to take the minus with the y?
Maybe. Maybe, do we take all of this?
What did you say?
You haven't got your book with you. You other guys, Michaela and Ellen and Jaden. Probably looking at the example C there. Looks like we take the x take 1 over, doesn't it? Would you agree, Michaela? Ellen's got the thumbs working.
What I did was, there's like, on the 3x take 1, take x plus take 1.
Yes.
Since there are 2 minuses, I just changed the second one into a plus.
Good point. So we're there?
Yep.
Yep. So then 3x take x plus 1 will come out, won't it? Is that what you're saying? So you see what we've done there? Put brackets around, which changes things up considerably. 3x take x equals 9 take 1 equals 8. Is that right, Ellen?
Yep.
So that'll be 2x equals 8, x equals 4. 3 times 4 is 12. Okay, so we reckon 4 goes into here then. Y equals 4 take 1. So we reckon y equals 3. So that changes from what we had here, doesn't it? Okay, let's do our check. 3x take y equals 9. We believe x now is 4. 3 times 4 take our y, which is is 12, take 3, equals 9. Yes, we did. Alright, so bear in mind when you bring these down, looking at the signs and how things change. This is a negative and a positive, so it stays a negative. This is a negative and a negative, so it must change to a positive. And that might be where you've got some incidences. Alright? Any questions with that? See how the check's really important? If we don't do the check, we don't know whether we've got it right. If we haven't got it right, then we get ourselves stumped, okay? We can always go back over it. We work out, okay, that's what else we could do, and that makes it better. Alright, so there's simultaneous equations, and blue group at the moment, you're sort of working out that x equals 4, y equals 3, that maybe simultaneously that might